In this video, I'm going to talk about greatest common divisors using Euclid's number theory, and which will lead us into the algorithm of Euclid. One of the definitions in his number theory says that if a and b are arbitrary integers, then an integer d is said to be a common divisor of a and b. If we have both a divisible by d and b divisible by d. What that means is we're looking for a greatest common divisor for integers a and b. The a and b are both non-zero, and then of course a finite number of positive common divisors exist in between them. To elaborate that, I give you an example of integers 12 and 30. They are non-zero, and we'll see that there is a finite positive common divisors in between 12 and 30. We always write 1 because in composite number we have the integer divisible by 1 and itself, so there is 1 and 12, and then the common divisor or the divisors in between are 2, 3, 4, 6 and 12. Between 1 and 30 we have divisors 2, 3, not 4. We have 5, 6, 10, 15 and 30. So between these positive divisors we have common numbers 1, 2 and 3, and then 6. 6 being our greatest common divisor. The symbol is GCD of 12 and 30 equals 6. So this is an excellent way to find greatest common divisors for small numbers. However, when it comes to finding the GCD of larger numbers, this process becomes cumbersome. So Euclid came up with a more efficient process in his Elements. Say for a large instance, large numbers such as 12,378. Finding GCD of 12,378 and 3,054. What would be the greatest common divisor between these two numbers? So in this method we are going to divide 12,378. Let me use a separate piece of paper. Of course I'm going to use a calculator as well. We're going to need calculator for finding the quotients and remainders. So here we are. We divide 12,378 by 3,054. 3,054 times 2 is around 6,000. It's nowhere near 12,000. We'll do times 4. Let's see. 3,054 times 4 is 12,216, and that's the quotient. That's 4. The remainder should be 162. That's our remainder, and that's our quotient, right? So this is how we're going to start writing this. Excuse me. $12,378 equals 4 times 3,054 plus the remainder of 162. 4 being the quotient, that's the divisor, plus 162. So mathematically we can do 3,054 and write it in the same fashion. This time we're going to divide 3,054 by our remainder 162. We're going to keep doing this until we find a remainder of 0. Remember, we're looking for the greatest common divisor. So 3,054 divided by 162. 305, so 162 goes only one time. We have 1434, and 162 will go 8 times. Using my calculator again, 162 times 8 is 1296. The remainder of this division is 138. That's my remainder. So to write it again, we're going to do quotient. Here's the quotient: 18 times 162. 18 times 162 plus 138. Now we have 162, which will be divided by 138. It will go only one time, so the quotient is 1 times 138. 162 minus 138, we have a remainder of 24. Correct? The next step is to divide 138 by 24. So 138 goes into 24, 24 times 5. 24 times 5 is 120. I just came with that off the top of my head. And then we have a remainder of 18, so it cannot go any further. That's our quotient. And we'll write it in the same fashion. We do the quotient, which is 5, times the divisor, which is 24, plus the remainder of 18. Are you with me so far? We have the next step, which is 24 divided by 18. Of course, 18 will go only one time, so the quotient is 18. The quotient is 1. It will go through 24 one time. 24 minus 18, we have a remainder of 6. And you can tell between 18 and 6, we'll have a remainder of 0, because the quotient is 3. And here we go. So the number before the remainder, the last quotient, is our greatest common divisor. So we write it again just like that. GCD of 12,378 and 3,054 equals 6, right? So here we are going to talk about the algorithm of Euclid, in which the theorem says here we go. The theorem says for integers a and b, of which both are not 0, there exist integers x and y such that GCD of a and b equals ax plus by. So there is a linear equation right there. A and B in our case is 12,378. So this is our A and this is our B. And we're going to find integers x and y to make a linear equation. So 6 is our greatest common divisor of A and B, and we have to find x and y. So we're just going to represent the linear combination, and we start with the next to the last of the displayed equation and successively eliminate the remainders. We have remainders 18, 24, 138 and 162 to find that linear combination. We start with 6 again over here equals 24 minus 18. How did I get that? This is the part where we have to pay careful attention. Over here, 18 times 1 is 18. If we have 6, 18 can be taken over to the other side. It becomes 24 minus 18. So we start right here next to the last, okay? We're eliminating the remainders. So here we go. Since 18 is our remainder on the step before that, we're going to try